I get a lot of questions in both my Discord server and also occasionally in my YouTube comments about the /execute if data command. And I think it's for good reason. This command is very strange. Lots of people have issues with it, and lots of people seem to think it's way more limiting than it should be. So what exactly is the problem? Well, I've gone ahead and put a little bit of NBT data into a storage slot, just an example slot, to highlight exactly what people's complaints about this command are. So if I go ahead and show this storage slot, I've got a couple things in here. The first thing I want everyone to focus on is this key right here called object, right? So inside this storage slot, I've got a key called object, and it's pointing to this object that has two keys inside it. It's got number 5 and then key value. Now, if I wanted to use execute if data to test for the existence of data inside this storage slot, it would look like this. We say /execute if data storage and then the slot, and then I have to give it a path, right? And the path is the only thing I can give it from here. All execute if data does, seemingly, is test for the existence of a certain path. So for example, if I wanted to just test for the existence of this key called number right here, well, I'd give the path to it. So it starts with object, right? And then number is inside that object. So it's just going to be object dot number. And if I run that command, it will tell me it found the data that I was looking for. But herein lies the problem that lots of people run into. All I did was test for the existence of the key called number inside the object called object. I didn't test the number 5 at all. It's very common that people want to instead test for the stored data inside of, whatever NBT field it is. And I often get questions like, how do I do something besides just testing for that key? Is it just completely impossible? Well, no, but the way in which you do it is so strange, and this is why I wanted to make this video, because I feel like a lot of people just don't know this about data paths. Okay, so what exactly am I referring to? First of all, it is absolutely true that execute if data only ever tests for the existence of whatever path this is. However, the thing that people aren't generally aware of is that these paths can have conditions on them. So if I want to test this object to see not only does it have this key called number, but that number specifically points to 5, well, here is how I would do that. And you can pause the video, take a look at this command for just a second. It's very weird. You'd expect there to maybe be a colon between object and number, and there's not. It's just directly a bracket like that. If I run this command, that will also pass, but then you can see that if I change number to 4, for example, that will fail, right? So I have successfully tested for the existence of a key called number pointing to the value 5. Okay, so how exactly does this work? Well, as I've said a few times already, it is true that execute if data only tests for the existence of a certain path. The trick is that paths can have conditions on them. So what we're actually doing by passing in this path right here, which by the way, this is still considered a path in case you were wondering, what we're doing with this path is simply testing for the existence of the object called object, and then we're giving that object a condition that it has to contain this data inside it. So just to maybe demonstrate this a little bit better, instead of execute if data, let's say, what if we were doing /data get instead? Now this is still a valid path, right? You can always pass in a path to data get. If I run that command, it will, oh gosh, sorry, I have to actually match the data correctly. So if I run that command, it will return that whole object, right? So what I've actually done here, this path returns the object called object under that storage slot. And all this part does that I've highlighted right now is just make sure that when it's returning this object has to have data inside it that matches what's highlighted, which it does, you can see right here. And I kind of did this by accident, but you can actually see the last command I ran, it still failed when I tried to pass in number 4, because that object doesn't have number 4, it has number 5. So, in general, this is how you test for specific data entries using /execute if data. You type out the full path, right? So maybe there could have been objects before this, like foo.bar.whatever. Type out the full path up until you get to the object containing the final piece of data that you want. And then, after the name of that object, you directly put in the brackets, and then from there you can just test, whatever data is inside that object. And that will return true or false based on if that data matches. Keep in mind it is a partial match, so you can see that the object does have another key inside, it has key value, and I've never been testing for that, but this does still work, right? If I put in number 5 right there, and the path was correct, this would still work because it's only a partial match, not a total match. Alright, so what I just showed you should cover pretty much any data testing needs you have, provided that all of the data is just under a simple object structure. But there's an additional complication when we have things like lists. As you can see in this same storage slot, I've also included a list, and it's a list of 2 objects and then 1 string. Now if I actually kind of zoom in and just show the contents of that list, well, we've got 3 objects here. We've got the first object that has A1, B2, and then color red. Then we've got A1, B3, and then color blue. And then the last one is not even an object, it's just a direct string entered inside that list. So one question someone might have is, how do I exactly test and match the data that's stored in this list, right? Lists are not exactly the same as objects, so what kind of data path wizardry do I have to enter in order to test this data right here? So we'll start from the basics that probably most people know, right? I can do execute if data, the slot, and then I can just see if list exists. Obviously that works. I can also see if individual entries in that list exist, right? So I can pass in, list 0 like that will give me, it'll test this first object right here. If I run that, that also works. What people don't know is that you don't necessarily have to put numbers inside these brackets. This is a really weird thing about lists. If I just put brackets like that with nothing inside them, it'll test every single piece of data in the list, and actually what this is going to do is return the number of entries in the list, which is 3. So for those familiar with other commands and like target selectors, this right here is kind of the same thing as like a command fork, but it's a NBT data version of a command fork. A command fork is like when you call @A or @E and it returns multiple entities and runs on all of them. And actually you can see that pretty clearly if I try to run this command using /data_get, right? It'll give me an error because data_get can only return one value, but that path that I just put in returns 3 values, and so data_get really hates that. Okay, but your next question might be, okay, how do I filter those objects down a little bit more? Obviously you can filter them as I did before by just putting in the direct index of whichever object you want, but like what if, for example, you don't know the exact index of the object you want? What if I look at this list up here and I say, rather than just wanting the object in position 0, what if I want the object that has b equals 2? Right? So this, the first one has b equals 2, the second one has b equals 3, but what if I don't necessarily know that? I just want to grab the one that has b equals 2. Well, you can do that like this. Instead of putting a number inside those square braces, you can put a curly brace inside the square braces, and now what this is going to be doing is testing all of the objects inside of that list. And it's important that you note that it's testing all of the objects because this string is not an object, and so this will be ignored by this particular filter. So to test for the object that has b equals 2, I'm going to say just b2 right there, right? This is just an NBT object. You can put whatever filters you want inside it. And there we go. It says I have that, test passed count 1, and I'll show you what it's actually returning by doing data_get instead of execute if data. It's returning just that object, right? It's the one that has b equals 2, and it returns the whole object, including A1, B2, color red. And since it's returning a whole object, you can actually go even further with this filter, right? Because this filter returns an object, I can then select keys inside of it. So if for the one that has b equals 2, let's say I want to know its color, right? That returns just red, which is really cool. If I want to test if its color is red instead, I can just go ahead and add color red inside that filter right there, and that will return that same object, and it will return true if I'm using execute if data. I also included, 2 of the objects in this list both have a equals 1, just to show you that if I put A1 right here and I'm using execute if data, it'll return 2 because that's how many objects had A1. Okay, I've been rambling for a while, but really the moral of the story here is that execute if data is a lot more powerful than people give it credit for, and that power comes from, the fact that data paths are so versatile and can have so many like weird conditional stuff like this. I basically never see anybody talking about this in like various Discord servers, YouTube videos, whatever, and I get lots of questions about it, so I just thought this video would be really helpful. And as far as objects and lists go, that's basically it. I think the last question I could possibly foresee someone asking is, how would I test for the existence of this string inside the list, right? Because those list conditionals I was doing before only work on objects inside the list, so how do I test for things inside the list that are not objects? And it turns out you do that by testing the object that the list is contained inside. So what do I mean by that? Well, in this case, the list is contained inside the root object of the storage, and so I can just start the path by specifying that object. This is a valid path, by the way. It just returns the entire storage. So this command right here in its current form just tests for the existence of any object at all stored in this storage slot. But like I said before, as long as you have that, curly braces in a path, you can start putting data in it to make it a partial match. So if I want to specifically test for an object inside this list, or I guess in this case a string inside this list, I would start by putting list in here, making it a list, and then saying string. And then if I run this command, this will return true if that list contains a string called string. But let's say I spell it wrong, right? Then that will return false because this spelled wrong string right here is not included in the list. I don't exactly know how you're supposed to test for the fact that the string is exactly the third object, right? So we've got this first object, second object, and then the string. And I don't think there's a way to test for that exactly being the case, right? Like really all you can do is just test that this exists inside the list, or you could test for the existence of the second element, right? List 2 would point to that string. Okay, and I've shown basically what I initially intended to show with this video, but while we're on the topic of data paths and objects and returning data and stuff like that, there's a few other things I learned about recently that I thought would be also really interesting to include. I mean, they're kind of tangentially related. I showed you before that if you're using execute if data and you just do list, like with brackets like that, then the return value will be the number of entries in the list, right? So it returns 3. And of course you can use that with execute store to, count the number of objects in the list. But did you know that you can also do a similar thing with objects? I've gone ahead and added a scoreboard objective over on the sidebar so we can actually store some return values. And if I run this command right here, right? So I'm storing the result as, this score that's over here on the sidebar, and then I'm just going to run data get storage and then just get the object. What actually shows up in chat is the object, because I just ran data get, obviously, but what shows up in the result is the number 2. It turns out that the return value of data get, if the returned value is an object, well, that return value will be the number of keys inside that object. So this is the only way I know of to actually count keys. There's a similar weird behavior if it returns a string, right? So object.key points to this string right here. If I do that, well, it'll return the value that was stored at that key, but the return value you can see over here is 5. Now what could 5 possibly mean? Well, 5 is the length of the string. So you can actually count the length of strings using this method as well. Both of these tricks are something that I didn't even know about until like a month or two ago, and I think they've been in the game for a long time, so you learn something new every day, right? If you do a similar thing with lists, it'll return the list, and then the return value is the length of the list. That's slightly less exciting because I already showed you a way to get the length of a list, but that's just an alternate version if you want. And then any other type of value, if I point to the number right here, it'll just return 5 because that was literally the number stored there. It'll take any number and round it down to the nearest integer as the return value. I'm sure most of you already knew that, but covering all our bases here. And I don't know how to end this video. Thank you so much for watching, my dudes. I've been Conyer. I will talk to you later.